Hello, my name is Ines Diko. So I'm going to talk about my assignment of statistical machine learning, where we have data set for binary classification with the prostate cancer. So the main goal is to understand the structure of the data set, to look informative gen, study correlation, microlinearity, and compare the running machine like K-mean, classification trees, including performance of losing using log, curve, and the other that statistical way that can use to understand the data set. So for me, when I look for the data set, I have the 79 samples and I have 500 features. That means my K, which is N over P, it is very small. That means the zero over feet and distance will be meaningless when I use the K-nin, and the distance will be meaningless. So apart from there, I look about the distribution of the data set. So where I have to for the classification, they are more likely to be the closer when you have for zero, we have 0.46 and the other we have 0.56. That means the range is the difference is not big. So that means there is imbalance in between the variables. So apart from there, I look about the cross where strong to look at the strongest variables using statistics. I just here put the top nine, but there's others. So this top nine, as long as the statistics big, that means that there is a strong and a stable in modeling. But when there's a small, that means there is a weak one. So apart from there, I use for the to look for the distribution of those the top nine. So you see here the top nine, the distribution. Some of them are the skew on the left, and others are somehow the skew on the right. So apart from there, I look about the using the log curve to see how the data are varies. So here I look about I see that when I use a Canaan and the tree, I see that the orange are above. That means the true positive and the meaning of the model and the stable. Apart from there, I look about the correlation using correlation and to test the error distribution. This is the error distribution using box plot. And we have on using ANOVA, I see that the variable are significant. So the high bias and no variance. Another thing is look, the p-value are so small. So that means there is a significance for the variables. So apart from there, you see that the t-tests are small, they're good. And another thing, I go to the first, second question where I have to use the KNN to look for to prove the different distributions. And I see that where we have KNN, which is small, it is good. And we have when KNN become a large, I saw that is not good. So I see that we use them to score that. We interpret it by using probability posterior, locally, and classification in done by Strayhorn that estimated probability. So the overall, what I have learned from my assignment from question one, question two, and question three. So the main takeaway we can say about this. When you're having the high dimensional like that, we have P, which is equal to that the flexible model can be fit training data extremely, but may generalize poorly. So when you go to generalization to not good because of for higher dimensional gen. And so we need to feature selection, general regularization, and repeated validation to balance the model complexity and the variability. That means uh, our model to be good, we need to regularization, to repeat validation more times. When you repeat more times, it can give us like some intervals where the data are varies and the model will be complexity. So thank you for watching me for this. Thank you.